Welcome. So in this series of podcasts, we're going to be looking at antidifferentiation. So antidifferentiation is the art of finding the function f of x whose derivative would be the given function f prime of x. In other words, there we go. Given, always takes the pen a little while to start writing. Given the derivative, what's the function? So antidifferentiation is also called indefinite integration. And just as dx represents finding a derivative, the symbol with the elongated s there, f of x dx, means finding the antiderivative. That's a tongue twister. Okay. So, for instance, ddx x cubed means take the derivative of x cubed. So the derivative of x cubed, okay, which I could write as dy dx, or f prime of x, or y prime. Okay, different ways to describe derivative there, notate derivative. The derivative of x cubed would be 3x squared. We would use our power rule. This would be the power rule for taking a derivative. And the exponent would move in front, and we decrease that exponent by 1. Right? So the 3 moved in front is a coefficient, and then we reduce the exponent by 1. Okay? So that would be taking the derivative. Taking the antiderivative, means what's the function who has 3x squared as its derivative. Okay? So the function that has 3x squared as its derivative is x cubed. Okay? So we're just going the other way. Okay? So where it says f prime of x equals f of x, okay, means we're given the derivative, okay. That's a derivative, right? Let me see if I can squeeze it in there. Derivative. There's our derivative. Given the derivative, what's the function? Okay, so x cubed is the function that has 3x squared as its derivative. Okay? So when we're differentiating, we know the derivative, we want to get back to the original function. That's going to be notated with this elongated s, which is called an integral symbol. The reason for the elongated s is it does represent sums. It won't be clear why it represents sums in this particular lesson, but in the future it will be. And just like we have to when we're taking the derivative, right, we need to note what are we taking the derivative with respect to. Okay, we're taking the derivative with respect to x. We need to show that what we're taking the integral with respect to. Okay, so this dx has to be part of our integral there, and it shows with what variable we are integrating with respect to. Okay, so the dx means we're integrating with respect to x. That's the variable in our function there, and the function who has 3x squared as its derivative is x cubed. Okay, so when we're taking the antiderivative, we're essentially going the other direction. We're going from the derivative back to the function. Okay. To give you a little bit of a sense of what we're doing when we take the antiderivative, I thought we'd play everyone's favorite game show, What's My Function? Okay. So I'll give you a derivative and see if you can tell me the function that has this as that function as its derivative. Okay. Now, in reality, when you are finding the antiderivative, when you're anti-differentiating, you're going to have more tools in your toolbox than just being able to figure it out intuitively. But I think it'll give you at least a sense so that when we go through some of the rules and some of the steps, those steps will make sense. because you've had a little bit of experience with antidifferentiating with a few functions that maybe you could figure out in your head. Okay? All right, so I'm going to give you derivative, and you tell me the function that has that as a derivative. Okay, so you can put these in your notes. By the way, the important things that I would write down from these notes here is what our definition, anti-differentiation, what that means, and that definition as well. Okay, I'd write those two things down. You can write more, certainly. More is not bad, because you can pause the tape and you can write down every single thing you want. But at a minimum, I would know those two things. Okay? And so in those same notes, you can write these ones down. And if you make a mistake, just put a no next to yours and put the correct one. Okay? No big deal. This is just giving you, some practice and giving you maybe an intuitive sense of anti-differentiating. All right? So I'll give you the function. You tell me the derivative. I'll give you the derivative, other way around. I'll give you the derivative, you tell me the function. All right, so f prime of x equals 10. All right, so that's the derivative. What function has that, 10, as its derivative? Okay, pause the tape, write down your answer. And then you can play it and find out the correct answer. Welcome back. Okay, so if you wrote down 10x, you are correct. The derivative of 10x would indeed be 10. Right? This would be a power rule. Okay? So it would be the coefficient, and the exponent is a 1, so the 1 would move in front. 10 times 1 is still 10. And we would do, oops, I didn't mean to put an equal sign there. And we would reduce the exponent by 1. Right, if we're thinking about the steps in the power rule. Right, so that would give us 10 times x to the 0, which is 10. 10 times 1, which is 10. Right? Anything to the 0 power is 1. Okay, so this was a power rule, and the derivative, the function that has 10 as its derivative, is 10x. Okay. Here's another one. All right, so here's the derivative, 2x. What function has 2x as its derivative? Pause the tape and write down your answer. Hey, welcome back. The function that has 2x as its derivative, again, this would be a power rule, is x squared. If we take the derivative of x squared, we get 2x. Okay. One of the nice things about anti-differentiating is you have the answer, so you can't always check your work. The answer is 2x. If I take the derivative of x squared and I don't get 2x, then I have a problem. Okay. So if I choose a function and I go to take the derivative and it doesn't match, then maybe I've forgotten something. All right, so here's my next one. The derivative is 5x to the 4th. What's the function that has 5x to the 4th as its derivative? Okay. Welcome back. If you wrote down x to the 5th, you are correct. If I take the derivative of x to the 5th, the 5 moves in front, and I decrease the exponent by 1. Okay, so it would be 5x to the 4th. Trig 1. All right, so the derivative is cosine x. What function has cosine x as its derivative? Okay, pause the tape and write down your answer. Okay, welcome back. If you wrote down sine x, you are correct, because the derivative of sine x is indeed cosine x. Sine x. Okay, so the derivative is sine x. What function has sine x as its derivative? Write down your answer. Okay, welcome back. If you wrote down cosine x, you're only partially correct. It would have to be negative cosine x, because the derivative of cosine x is negative sine x, and the two negatives would cancel, giving us positive sine x. Okay? So that was a little trickier. You had to remember that the derivative is negative for cosine x. And so if our derivative is positive, it must mean that our original function had a negative in front. Okay, so correct answer for this one was negative cosine x. Okay, so here's our derivative. F prime of x is 1 over x. Which function has 1 over x as its derivative? Okay, pause the tape, write down your answer. This one is a little bit trickier. It is not a power rule. And if you wrote down natural log of x, you're correct enough for me. I'm impressed enough. If you put the absolute value bars, I'm really impressed. So because this has to be positive, whenever we take the antiderivative for 1 over x, where our answer is going to be natural log or log, we have to make sure that whatever follows is going to be a positive number. I don't know what x is going to be. Right? So to make sure that no matter what, this is positive, I need the absolute value bars. Unless there's absolutely no way for this to be negative, I need the absolute value bars in there. Okay, so because x, if I substitute a negative number there, I'm going to be taking the natural log of a negative number. I need those absolute value bars to make sure that no matter what, x is positive. Okay. So that was a little bit trickier. It looks like it's a power rule, but it's not. Okay. So if you changed it and you went to figure out this, f prime of x is x to the negative 1, and you were trying to figure that out, what would that be, negative 2? Would that be 0? Nope. It wasn't a power rule at all. Okay? It was natural log. And if we take the derivative of natural log of x, right, it would be 1 over x. 1 over whatever we're taking the log of. Okay, so here's our derivative, e to the x. What function has e to the x as its derivative? Welcome back. I almost gave that one away. But I think you probably figured it out anyway. The function that has e to the x as its derivative is e to the x. So e to the x is its own function. It's its own derivative. It's its own integral. So whether we're taking the derivative or the antiderivative of e to the x, the answer is e to the x. But how about this one? So the derivative is 2x e to the x squared. What function has 2x e to the x squared as its derivative? Okay. So take a moment, write down your answer. Okay, welcome back. Right, so anytime, let me give you the answer first, and then if you wrote down e to the x squared, you are correct. Anytime we take the derivative of e to the x, if this exponent here is a function, right, now we have a chain rule. So we have to take the derivative of, right, like this. So we have to take the derivative of e to the x times the derivative of that inside function there of x squared. So our derivative would be, the derivative of e to the x would be e to the x, and the derivative of x squared would be 2x. Oops. Sorry. So it would be e to the x squared, sorry. The x squared still would be there as well. So we have to take the derivative of just the e to the x part, or e blop. That may be a better way to explain it. Remember when we started off the chain rule? We would take the derivative of e blop. So, oops, I wanted to write derivative, take derivative. Right, so d dx e to the blop times the derivative of the blop. Right? In this case, so we'd have our derivative would be e to the blop times that derivative there. Okay. And our blop is x squared. So our derivative is going to be e to the x squared times the derivative of x squared. And the derivative of x squared is 2x. Which gives us 2x e to the x squared. So, if you said this was the function that has this as its derivative, you are correct. And that's where I'm going to stop. Okay? So in the next series of lessons or podcasts, I don't know how much I want to break it down, we are going to be looking at some definitions and some tools, some procedures, some how-tos, rather than an intuitive sense. I'm going to give you a step-by-step, how do you take the antiderivative of some different functions, and I'm going to give you some formulas that you can write down and keep. Okay? So I'll see you in the next podcast. I hope you enjoyed playing our little game, What's My Function? And I'm sure it's now going to be your favorite game show. See you later.